Welcome to Easy Math TV. This is going to be the first in a series of StatCrunch videos for an introductory statistics class. And we're just starting to actually work with data in our class. And the first things that we were doing with data was making a frequency table, possibly a binned frequency table or a grouped frequency table, and then how to make a histogram with our data. So we're going to work with three different types of data today. Here in front of us, we have some data that has lots of different columns, lots of different information, but we're going to be focusing entirely on just the commute distance column. These are just average commute distances for each of these cities in the United States. So, so each one of them is basically an average. But we just want to take a look at like how these numbers appear. Are they spread out? Are they, does there seem to be a place where like the vast majority of them seem to be clustered, or, and then we want to talk about the distribution or the shape of the data. So the first thing that I should point out is that these commute distances are continuous. This is a continuous data set because the numbers are decimal values. So that's right there, your clue. Like the minute that you see decimal values in your data, you can say, oh, this is continuous data. So the minute that you know that it's continuous, we are going to be binning our data. So the first thing we're going to do is go to the Stat menu, Tables, Frequency Table. And we're going to just work with the commute column. So I had to click on that. And then these two we're going to ignore. And then what we want is we want the frequency and maybe the relative frequency. For future purposes or for certain types of problems that you're being asked, you may want to also select the cumulative frequencies and the cumulative relative frequencies, because those are your percentiles. And you may be interested in knowing those two in the future. But let's just, for now, just focus on frequencies and relative frequencies. And then what's really important is that we go down here and we click on the box that says bin numerical values. And we don't need to specify a start at or a width unless that is something that, like, it's in a homework problem and we're being asked to create a frequency table with a specific bin width. Then you would type that in here. So we're just going to leave those two alone for now. But if it's specified in the problem, then you need to type those numbers in here. So I'm just going to hit the compute button, and it shows up as a pop-up window. And here's our bins. So our first bin starts with 15 and goes up to 17.5, but does not include 17.5. So that's what we call a left closed interval. It starts with 15 and includes the 15, and then goes all the way up to like 17.49 or 17.499. But the minute you get to 17.5, you have to go to the next bin, and then that goes up to, but not including 20. So if you had a number that was 19.99, it would go in this bin. So those are your bins. The frequencies are the counts. So there were 2 cities that had an average commute time of between 15 to 17.5, not including. So only 2 of them. There were 6 cities in the second category, and then there were 25 cities in the third category here, and then 15 on down. So the frequencies are going to give us the heights of our rectangles when we make our histogram. So I want to show you right next to this, I want to show you what the histogram looks like. Again, we're going to choose commute times, and it is a frequency histogram. We're going to include the value above each bar. So I want you to see I want you to actually see what those frequencies look like. and how we had measured the heights of those rectangles that are showing up in our histogram. So again, commute, and and then it's frequency, and then click on the box that says value above bar. Okay, let's hit compute. So there's our frequency, or sorry, there's our histogram. So the first bin from 15 to 17.5 is here. This is our first rectangle. It has a height of 2. The second rectangle has a height of 6, and then a 25, and then a 15, and so on. So if you're being asked to make a decision about your data in terms of like the shape of the distribution, so how are these values distributed across the range? So from going from 15 all the way up to 40, how would we describe this distribution? Okay, and that just means like kind of the overall shape of it. And since the tallest rectangle is way more to the left, the center is right here between 25 and 30. Like this is the center of our data. But that's not at all where the tallest rectangle is. The tallest rectangle is way over here to the left. And then we have these like short rectangles that are kind of going off to the right here. The way we describe that is we call that right skewed. The skewedness has to do with where there's, if there's a tail, or if there's like numbers that are kind of extending to one side or the other, that's where the skewedness comes in. So this is a skewed distribution, and it is skewed to the right. It is a right skewed distribution. Let's look at another. This is going to be a discrete data set now. This has to do with numbers of siblings of the freshman class at some private college. And there were 150 freshmen in the class, and they were all asked, they were surveyed about how many siblings they had, and these were their responses. So this is discrete data, and we don't expect the numbers to be very large. We expect them to be somewhere from either 0, 1, 2, 3, maybe up to 10 or 11, but not much larger than that. So we are going to go to the stat menu again. We're going to make a frequency table, but this time we're not going to be binning the data because this is a discrete data set. And again, I'm going to choose frequency and relative frequency, and we're going to leave this box down here alone. We do not want to choose that box. And I'm going to hit compute. So these are all of the responses that were given. And you'll notice there's a big gap between 6 and 11. Somebody actually has 11 siblings. So 5 people had 0, 25 people had 1, 36 people had 2, and so on. So it's hard to get an idea of what the distribution is from this, like, is it skewed, is it not? So we're going to go under the graph, we're going to make a histogram, and again, this time we're going to, I'm going to put the value above the bar, but hopefully it's not going to bin the data by much at all. It's just going to make like a bar graph. And there it is. There's our vertical bar graph. So 0 siblings, there were 5. 1 sibling is 25, and then there's 3, there's 4, there's 5, 6, and then all the way up to 11 is up here to the right. So again, this is just it's slightly different than the first data set we looked at, but the more of this data you look at and the more examples of histograms and frequency tables you get to see, you will get a good practice at recognizing when it is skewed and when it is not. So again, this data set is definitely skewed because you have some outliers off here to the right. And the tallest rectangles are not in the middle of our data set. The middle is somewhere between 5 and 6, and we not at all is that where the average or the largest number of values is all the way down here to the left. So this is another example of a skewed data set, but it just happens to be discrete instead of continuous this time. Let's look at one more. This data set is one you're going to load for yourselves in class to kind of reproduce what it is that we're doing here. These are measurements of possums in Australia and New Guinea. And what the goal of the research was here was they wanted to know if you could predict what the total length of a possum was by just measuring its head, because it's a lot easier to just measure one thing on an animal and then be able to predict other measurements that are probably a little harder to get. And the head is a little more manageable. So, they wanted to know if you could predict. So what we're going to do is we're just going to look at the one column of head lengths here. And again, notice that there's decimal values there. These are numbers in centimeters, and they are decimal values. So again, we have continuous data. So we're going to go under the stat menu and make a frequency table that is going to bin the values. And I want to choose head length. So head underscore L is head length. And again, we're going to do a frequency. We're going to show the frequencies and the relative frequencies. Just because that's what you should kind of default to. If you wanted to know any of the percentiles or the quartiles, you would choose cumulative also. But let's not. So let's just do the binning and okay. Compute. So your frequency table should look like this one if you chose everything the way we were supposed to. The smallest head length was 82.5, and the largest one was almost up to 105. It was somewhere in this range from 102.5 to 105. If you want to know how to calculate the bin width from this, you take two numbers on the left and subtract. So 85 minus 82.5 is exactly 2.5. So the bin width is 2.5 centimeters. So these are our frequencies here. And let's go ahead and make a histogram also of head length. So head underscore L. This is a frequency histogram. And I am going to include the value above the bar and compute. If you don't like the blue, you can change the color. It's not a problem. So this may not look like it, but this is symmetric data. This is a bell-shaped distribution. And the reason is because the tallest rectangles are, in fact, exactly right in the middle. And things don't have to be perfectly symmetrical. One of the things that we are learning about is that there's always random chance variation of a sample, and that random chance variation can make things look a little bit different than a perfect bell curve. So this is what random chance variation looks like from a perfect bell curve. But the two tallest rectangles are in fact right in the middle here, right in the center. And on both sides, the rectangles slowly get shorter and shorter down to the end. So that is, in fact, a symmetric bell-shaped curve of head lengths of possums. So that's your introduction to how to do a frequency table and histogram in StatCrunch with just a set of data. And I hope that you will like, subscribe, comment down below, and I'll see you in the next video.